couple examples here of solving rational equations. The method I'm going to use here is basically eliminating the denominator. So the problem in front of us, x plus 3 over x equals 4. I see that the only denominator is an x. So I'm simply going to multiply both sides by x. So this side, on the left-hand side, I'm going to x times x, which is x squared. Now x times 3x, realize I got 3x times x. The answers, the x's go away, as you will. So I'm left plus 3 equals 4x. Get everything to one side, subtract 4x. All right, and then I can factor that. X, so I believe that's x minus 3 times x minus 1 equals 0. And that means x is 3 or x is 1. And I recommend we always check our work when we're working with rational expressions. So back to that original expression, equation, x plus 3x equals 4. If I put in 3, I get 3 plus 3 over 3 equals 4, and I believe it does. If I put in a 1, I get 1 plus 3 over 1 equals 4, and that works. Okay. One more sample problem. What if I have a problem like x plus 1 over x minus 4 equals 0. I like when they equal 0. Once again, the only denominator is x minus 4, so I'm basically going to multiply both sides by x minus 4. Now, the right-hand side is going to be 0. Left-hand side, I'm just going to write down x times x minus 4. And then I've got x minus 4 over x minus 4, which convince yourself that is 1. So now you got x squared minus 4x plus 1 equals 0. Not real happy about that. I can't factor it, so I'm going to go with the quadratic formula. Okay, so the opposite of b is 4 plus or minus the square root of negative 4 squared, which is 16, minus 4 times 1, which is 4, all over 2 times 1, which is 2. So now I got to just do some cleanup here. 4 plus or minus the square root of 12 over 2. Square root of 12 is the square root of 4 times the square root of 3, which is 2 root 3. So now I got 4 over 2 plus or minus the square root of 12. Actually, I'm not going to do the square root of 12. I've got 2 root 3 over 2. Those 2's cancel. That one simplifies to 2. So I got 2 plus root 3 and 2 minus root 3. Now what we should do at this point is get the decimal approximate of those two values and then check on my graph. Check the graph to see if those two zeros exist, and they are the zeros.